Hello everyone and welcome to the second part of the series on creating an IoT application on SAP HANA Cloud Platform. In this part, we look at how we can create a UI5 and HANA application on top of our IoT service data that we created in the previous part. In the last session, we created a HANA trial account and got familiar with the HCP cockpit. Then we used the IoT service to create some message types, devices and device types. Then we configured the IoT MMS service on our trial account to use our HANA instance. We published some messages on the IoT tables using the IoT MMS cockpit. And finally, visualize the data that we created in form of tables in the IoT MMS cockpit. In this part, we start by getting familiar with the HANA web-based development workbench. We learn about some of the different views in it and how we can use it to find and query our IoT tables. Then we look at how to create some odata services to expose our IoT table. Along with this, we'll be creating and managing roles, privileges for our HANA Access application. And finally, we create an SAP UI5 UI to display our IoT data in form of responsive table. Alright, so let's get started. Now open your browser and go to SAP HANA Cloud Platform Cockpit. This time in your dashboard you would see one application already running. This is the IoT MMS application that we used last time to create and insert some data into our IoT tables. Now let's look at those tables in our SAP HANA instance. So go to HANA instance and open the SAP HANA web-based development workbench. This is the web IDE that we use to work with SAP HANA on HCP. By default, your workbench would open in the editor mode. This is the mode that we will be using for creating our application and the different files involved. You can find out some existing applications also here, which are the packages created by SAP. Apart from this, in the top menu, you can see various features. One of them would take you to a different mode. So you can click on the plus and click on the catalog mode. These are the different modes available. So clicking on the catalog mode would take you to a different page with the catalog mode open. The catalog mode is used for working with schemas and the different objects inside them. These could be tables or your views. Now here you would see one schema which is of the form neo_a_grid. This is the schema that the IoT service created for us when we created the message types. On opening the table dropdown, we can find the different tables in the schema. The first table is the table created for our message type. You can double click on it to find details, and you can see that the column name and the data type correspond to the values we created. So an important thing to observe here is that by using the IoT services, we did not have to bother about the manual creation of these tables and specifying the data type and the dimensions involved. So this was handled by the IoT service for us. Now if we want to see the detail of the table, right click on it and click on open content. This would fire a SQL query and we can see the data in the below. So this table is the same table that we were seeing from the IoT MMS service. Just to verify, let's go there and go to display stored messages and let's go to our table. So you would see that it has the same column name and the same value, and even the table ID is same. So basically the IoT services have given us a way to create and model our IoT database without having an in-depth knowledge of SAP HANA. So apart from our schema, you would also find out some other schemas present here. These are things that are provided by SAP for you to play around or create UI applications or HANA entities on top of them. These tables are already pre-filled with data and can be used as a very good substitute for the remaining part of the exercise in case you don't have your IoT tables ready. Another handy feature here is the SQL editor that allows you to run various SQL commands and query your database. Let's try it. On the top menu, you would find an SQL button. Click on it. This would open a new tab where you can type your SQL query. I'll copy the query we already have. Let's copy it and paste it, and let's change few of the values here. So I don't want to see the device and created information here. I'll just remove those. Once you have your query ready, you can select it all and click on the execute button from the menu bar. This would execute your command and display the data in form of a table. Now let's create our first Access application. Switch to the editor view, and under the trial HANA package, let's create a new package. Right click over here, and from the options that we get, let's select create application. This would allow us to create an application from some existing templates. Provide a sub-package name here if you want the new app to be created under a different package. If you want it to be created in the same package, you can just click on this checkbox. And then we will select one of the existing templates provided by SAP. So click on this drop down and you can select any of the templates. What I'll select is a simple mobile application. This would create a simple mobile application based on SAP UI5. So this template creates an application package along with 3 files. The Access Access and Access Application file are something we'll be talking about in a while. In the index.html file, there is a simple application which contains 2 pages and a navigation. So let's just run this application. And here you get a simple screen with a mobile button, clicking on which takes you to the next screen. So we have our first application up and running. So now that we have our first application ready, let's go and create our IoT application. Create a new package. I would give it a name as IoT app. Now under this package we will be creating a lot of different files. I would suggest that you can directly go to this Git link and download the starter app. So what I've done here is I've created a UI5 odata app, and this contains a list of files which would give you a head start on this. So you can go to this link and download it as a zip. So let's just extract this file now. So what we'll be doing is we'll be copying these files to our package. So you can copy, select all of them and just put it on this drop zone. So this would create all the files that we just copied under this IoT application package. Now in the below you can see in the console and output log. So there would be few errors also that you get, and we'll look at the reason why we are getting these errors now. So in this IoT application we have all the files that we require to build the application. Let's look at all these files one by one. So the first file that you see here is the access file. This file declares that this package should be exposed and available as an access application. Now the second file is an access app file. This just has an empty curly braces, and this file signifies that the package that you're working on is an access application. So these are the basic files that you need to have whenever you're working on an access application. We would have seen this in the first application that we created, and we have an additional index.html. Okay, now let's go to the third file, which is the privileges file. Here we are creating a basic privilege that allows us to access the different entities that we will be creating in this package. Now the next file that you should look at is a role file. Here we are creating a HDB role that will help us manage the authorizations for this package. Now you will see some placeholders over here that you need to change appropriately for your application. So we'd be creating a role under this directory. So this would be your account name, your HANA instance, and your package name, and the name of the role. So we are saying the name of the role here is IoT service. Then we are using the privilege that we just created. So this would also follow the same file structure. It will link to the privilege file that we created. And finally, we tell that which schema we want to use for this role. So let's start changing this. Now, in case you have given a different package name, so this should change appropriately for you. So I have my package name as IoT app and the file name as IoT service. Now I'll follow the same pattern here and I'll save it again. Now on saving, you'll see some sort of an error here, and this is because we've not given a proper schema here. Now we need to get the schema. For that, let's go to the catalog view again and let's go to our schema. So this is our schema name and this is the IoT table that we want to work with. So a good way would be to get the SQL command for it, and we can directly copy the schema name from here. So just copy this and replace it here and save it again. So this time it gets saved and activated successfully. Now another thing that we want to do is we want to expose our table as an OData, and for this we are creating an OData service. This service just needs to expose our table along with another generated ID. So let's replace the schema name and also the table name and save it. So now we have an auditor service ready that checks for this role and this role checks for this privilege. So let's just run this service and see what is the data. Okay, so this auditor service works nicely. What we want to see is the internal table information. So just copy this link from here and paste it. Now this would give us an authorization error. The reason here is that we have created this HDB role, but we have not assigned this role to our user yet. So in case you're working as a team, you will need to assign all your team members to this role as well. Now we can do that in the catalog mode using the SQL editor. To assign the role, we'll be running a SQL command that you can also obtain from the Git repository. The command would be something like this. It calls the HCP grant role to user, and then you need to provide the role name and your user ID. So the role name and user ID you can get from this editor itself. So this is our role name and the user ID is your P number. So this would be your account name minus the trial. Now you can run the SQL command and you would see in the console below that the command was executed successfully and a role was assigned to you. Let's go back here and run this auditor URL, and this time we don't get any authorization errors. There's an issue with my browser. I'm unable to open the URL properly. So let me get the data as JSON by updating my URL. So you see we have the data of our table exposed to us in a proper JSON format now. Now let's integrate the service in our UI. For that we have created a UI5 application already that you can use. So let's get a quick understanding of what is happening here. In the index.html file, you'll see that we are bootstrapping the UI5 resources from the openUI5 library, and we are creating a simple mobile page and placing its content as the component container. Now this component container is loaded from the component.js file. In this file we load the different dependencies and the different files that we require. So we are loading the one view and one controller, and we are placing that view as the content for this component. You can check out the code for the view in the view.xml file. Over here we are creating a mobile responsive table that contains 4 columns. The values in these columns are coming from the binding which we have done to our view. So in the controller.js we are making one call to our odata service and then binding the resultant model to a view. So you would need to replace the service call with your service call. So you can just copy it and paste it here, and this should return the data in a JSON format. So you can save it. And that's all you need to do to get your application running. So let's test it now by running the index file. And over here we can see we are getting a mobile table that contains the values which are coming from our odata service. So now we have an end-to-end application consuming the IoT services and displaying it in a UI5 application. So now you can take this application as a reference point and start building your IoT apps. You might like to change the UI a bit based on your sensor information, probably show a chart and have some more OData services, or probably enhance how your application handles privileges. But what you have learned till now would enable you to create IoT applications on SAP's HANA Cloud platform. In the next part, we look at how we can connect a real device, something like a Raspberry Pi, to send data to our HANA Cloud platform and manage authentication from it. Till then, thank you for watching.